Well, thank you, Ann. After that setup, I think the only way to go is downhill. So hopefully I won't disturb your stomach too much as you eat lunch. I'll try my best not to do that. And by the way, that tart looks fabulous. I hope you guys leave some for me on the table back there. That really looks good. So enjoy that. And I'll keep my remarks relatively brief, but I did have just a few things that I thought I'd share with you. So just got it.
Yep.
Okay, perfect. So as Ann indicated, I'm Todd Brady from Intel Corporation. And to do just a brief introduction of Intel, I've got a short video here for you. I think it'll do a better job than what I can do and be more entertaining than I will be. But we're the world's largest semiconductor manufacturer, 100,000 plus employees worldwide. Here in the Phoenix area, about 11,000 employees. We have a very large manufacturing presence here and also in outside of Albuquerque, New Mexico in the Southwest. Of course, we're headquartered in California, Silicon Valley. So the issues of water in the Southwest, which I'll get into in just a minute, are very pertinent to us and the company. So, pun intended, let me leap into it here. So as you probably surmised, actually let me go back here, as you probably surmised, those were all just various applications that have our technology inside. As one of my colleagues from Qualcomm also spoke, as Molly indicated, the number of applications for silicon and for technology is absolutely exploding. And a very exciting time to be in the industry, but also an exciting time to be a consumer and to start thinking about the various applications. So before I jump into Intel and water and what does that mean, let me do a brief introduction of myself, simply because I think for all of us, kind of who we are shapes how we perceive water and the water challenges. It's all based on kind of our own perspective. So this is my perspective, 1969, the beginning. So you guys will either say, man, that guy is a baby, or that's one old dude. Okay, hopefully I'm somewhere in between on that, not too much of the old dude yet. But 1969, I was born in 1969 in upstate New York. And of course that was the year we put a man on the moon. In addition, that was a year that a very significant event occurred in the environmental movement to get the world's attention, or the US's attention. Is anyone here from Ohio? Does that picture look familiar to anyone? But yeah, the burning river, right? That is the Cuyahoga River. In fact, I had to go look up how to spell it. Or I saw how to spell it, I had to look up how to pronounce it. And apparently there's this big debate in Ohio if it's Cuyahoga or Cuyahoga. So whichever way you say it, it was the river that caught fire outside of Cleveland and got the attention here in the U.S., led to a number of regulations in the environmental arena, the Clean Water Act and other things that followed that really pushed the environmental movement here in the U.S. So that was 1969. Fast forward, and when I went to college, I actually came out west. And at college, I met this amazing woman who today is my wife, but her family liked to vacation in Lake Powell. Now I grew up, I was born in New York, and I grew up in Tennessee in the southeastern U.S. So my my worldview of water at that time was we've got too much of it. I grew up in Memphis, Tennessee, and every several years or so, the Mississippi River would flood. Memphis is up on a bluff on the eastern side of the Mississippi, and so we were always fine in Memphis, but on the Arkansas side, there'd be terrible floods every so many years. And so growing up as a child, I looked at water as more of a problem. There's too much of it, it floods, it ruins people's lives. Those are the images I saw. That perspective changed when I came out west and began to vacation then with my would-be wife's family. They like to go to Lake Powell every year. And you can see the images of when I first started going to Lake Powell in the 90s, and then fast forward to today. And very real for me in visiting that Lake Powell, that phenomenal location, by the way. If you guys haven't been, take the time to check it out. But to see that bathtub ring grow year after year really hit home the challenges that we have in the Southwest associated with water and availability of water. So I guess the question that I have for you today is, given this, is the water glass half full or half empty? And I will argue that although there are certainly challenges associated with water, the fact that we are here today talking about the issues, we have all the various constituents here today from all various industries, NGOs, policymakers, that although that glass may be half empty, in reality it's half full. That we have opportunities here, and it's a challenge that I think collectively we can address and overcome. So, the business of water, the criticality of business of water to each of our companies, each of our industries. It's been stated, and I'll get into Intel and what that means to us and why water is so critical for us. But clearly, it's a challenge that we look at often at a global scale. However, in reality, it's a local issue that we have to address, and here in the Southwest, we have to address it locally. So let me, one of the documents that Ann and team, and would like to thank her for the invitation, is a policy document which they put together, and I believe will be made available to everyone here at the summit. But there's a call to action in 4 different areas. I would encourage you to take a look at that in these areas that we can collectively work on. I believe over the next couple of days there'll be opportunities for breakout sessions to talk about each of these areas and what we can collectively do to increase water conservation and efficiency, reuse recycling, flexible water management, et cetera. And what I would like to do at this point is share with you some of the steps we're taking as Intel, certainly not the end-all be-all, but perhaps stimulate additional ideas for additional partnerships that we can participate in, or perhaps you can participate in going forward. So let me introduce Intel and water and what it means to us. So one of the tenets of our business is something that we call Moore's Law. Moore's Law, Gordon Moore was one of our founders 40 plus years ago when the company was founded. And in fact, Moore's Law achieved its 50th year anniversary last year. Moore's Law is a premise, and Gordon Moore actually said it was an economic premise that he identified. It was something he identified early on when the integrated circuit was first invented, was that the number of transistors on that integrated circuit doubled roughly every 2 years. And that's what we call Moore's Law, and that is the mantra that pushes our business forward, our industry forward. Every 2 years, doubling the number of transistors. What that means then is doubling the amount of compute power, doubling the amount of things that you can do with your devices today that were unheard of just a few years ago. With that, now how does that tie to water? Well, as you manufacture these integrated circuits, and they become more and more complicated, in fact, if you look at your thumbnail, an integrated circuit, if you were to open up your computer, your cell phone, or whatever, the brains of your device would be roughly the size of your thumbnail. Okay, that's about the size of an integrated circuit today on average. That device that's the size of your thumbnail today will have over 1 billion transistors on it. Each of those transistors is switching on and off 1 billion times. So you have 1 billion transistors, each switching on and off over 1 billion times. That's what makes the technology work. And that's Moore's Law. The challenge with that is to build those devices, it becomes increasingly more challenging, and increasingly more process steps have to be taken to do that. And one of the critical process steps that is taken in semiconductor manufacturing is to use ultra-pure water and clean off the surface of that wafer, which is what you see there on the right-hand side, in between each process step. You have to clean it off, make sure it's perfectly clean, and then go to the next step. If you don't, then you'll have defects in your chips won't work, your computer, your cell phone won't work, and we've got problems. So that's the tie to water and Moore's Law. So as a result, you can imagine water is a lifeblood of our business. It's something then that's critical for us. It's critical for, as it is for many of your businesses. As a result, it's an area that we've put a lot of investment in over time. You can see some of the statistics up here in terms of our water savings and water investment. Now that said, we still use as a company 9 billion gallons of water a year, which is a lot of water. And in particular in areas like here in the Southwest that are arid regions of the world. To put that in perspective, an Intel chip, the footprint of our chip between our supply chain and our use is about 16 gallons of water. That's about how much water it takes to make an individual chip. And you can see in perspective kind of how that equates to maybe other things that you're familiar with, to put it in context of the water use. So 16 gallons of chip doesn't sound like a whole lot, but we make hundreds of millions of those chips. So it adds up quickly to the 9 billion gallons that you see. So what I want to talk about then is, before I go there, let me give you just a brief case study. I mentioned we have a large manufacturing here in the Phoenix area. I want to step you through some steps that we're taking, and we're certainly not done, and we certainly have more opportunity. But some of the things that we've learned as we've gone through this process, and how do we operate in a desert where we need a lot of water, and what's the right balance that we can achieve by partnering. And by the way, this is not something we've done on our own. This is through partnerships with companies that are here, such as GE, who we use for water technology, such as the city of Chandler, where we get our water, such as SRP and CAP, who provide the water to those municipalities. So this is a partnership as we go through it, not something that we can do on our own. If you look at just a brief diagram of this is a very simplified diagram of how we use water in semiconductor manufacturing. We get water from the city. As I mentioned, we make a lot of this ultra-pure water. That water is then used to manufacture our chips. That water can also be used then to run our facilities operations. And these unit operations will look familiar to any of you who run manufacturing or similar things. Now, we can do some things to conserve the amount of water that we're using. So for example, ultra-pure water, which I mentioned is one of our biggest uses of water. 2 decades ago, it took about 2 gallons of water to make 1 gallon of ultra-pure water. You remove all the impurities. For those of you who have a reverse osmosis system in your home to get soft water, similar idea, just on a very industrial scale. It used to take about 2 gallons to make 1 gallon. Today, through technology advancements of companies like yours who are out there in the water space, we're now able to get about a 90% efficiency, which means about 1.1 gallon of water to 1 gallon of ultra-pure water. Significant improvement. Similarly, new technologies in cooling towers and new technologies in our process manufacturing. So all those things summed up together, we can get about a 15% reduction in our potable water demand. So that's a start. If we move forward then and take a look at reuse and recycling. Partnering here in Arizona with the city of Chandler, what we're able to do is take back gray water. Some of the previous panelists talked about purple pipe, gray water. We can use gray water in our operations, several million gallons of water a day that can run our facility systems, and can do that and we don't need potable water, we can use the gray water. That reduces our potable water demand an additional 20%. Now for the policymakers out there, from a manufacturing standpoint, It would be phenomenal if, as we're developing industrial sites, that we route those sites with purple pipe, with industrial water, because we would love to use industrial water or gray water everywhere we operate. The reality is we only have a few locations where we can do that today because we don't have the infrastructure of that water to our sites. So opportunity going forward, again, as we talk about how to work together, how do we make sure we get that gray water to the industrial sites where it can be used? And then lastly, flexible water management. So, and I wish I could take credit for this. This was one of my predecessors at Intel. But when we built the first semiconductor fab here in the Phoenix area back in 1994, one of my predecessors had the vision to go sit down with the city of Chandler and to forecast, to look ahead. We knew we wanted to grow. We knew we wanted to grow our business. Today we have 4 large semiconductor fabs. Back then we had 1. In order to do that, we knew that we had to be more innovative in the way that we used water. And so partnering with the city of Chandler, and in fact this is, I think on Friday, if you're interested, there's an opportunity to go visit this facility. But this is a facility that we funded, the city of Chandler now operates, and you can see it has a nice engineering name, Ocotillo Brine Reduction Facility. What the heck does that mean, right? Essentially, this is a way of taking water from our factory. That water here in the Southwest is very hard water. It's removing the hardness and then making that water available for reuse. And that can be done in a couple of different ways. One, it can be injected into the aquifer, recharged, a couple million gallons a day capacity to do that, or it can be routed back to us and we can reuse it in our facility systems or back in our manufacturing process. So you sum all of that together, and the net of these partnerships working together is we're able to reduce our water consumption by roughly 50% over what it would be. So the business case, obviously, for water is if we can do that, and if water is a constraint, that allows us still to be able to grow our business while using less water. So let me shift gears then and touch on something that Qualcomm mentioned with their smart city initiatives. As we look forward, I'm very optimistic about the future and the opportunity to better leverage IT into some of the water challenges that we face today. If you think about your life, how many, who can live without their cell phone? I know I can't. And think about all the applications that we do today with those devices that we didn't do just 10 years ago. I think we're at the infancy of integrating this technology into the world around us. And one opportunity to highlight is obviously agriculture. So we talked about the amount of water use in agriculture. We need agriculture. It's the lifeblood for all of us. However, is there an opportunity to use IT to be even more efficient in the way we use water in agriculture? And we've done a couple of different pilot projects. One of my colleagues is on a panel this afternoon. He'll talk specifically about a project that we have going here in Arizona in conjunction with BEF, Bonneville Environmental Foundation, the Nature Conservancy, and others to look at that. But it's a growing area. We did a pilot recently in Malaysia where by using IT to measure the moisture content for rice paddy fields, it turns out that there's an optimal, not being an agronomist, those of you who are going, yeah, the guy's he's a city slicker, he doesn't know what he's talking about, which is true. But it turns out there's an optimal amount of water that you have at any time to grow rice to get the optimal yields. Well, using IT, in Malaysia, we were able to put sensors in, deliver the optimum amount of water to those rice fields, and the result was a 50% increase in yield because they were able to get in an entirely new growing season within a year for rice, and at the same time reducing the amount of water. So the opportunities are out there, and honestly it's on us as IT companies to deliver some of the solutions that still need to be there at the right cost point and reliability to be successful. So that said, I want to share with you one more video, and as you look at this video, this is really a science project, but I want you to think about possibilities as you're looking at this.
Issues that farmers face because of the ongoing California drought and the current methods they use for irrigating their crops. Currently, most farmers' greenhouses do not use any type of targeted or measured irrigation system, and the goal of this project was to prove that a precision irrigation system could save quite a bit of water.
We've maintained constant light so through those tube lights, and also it's in a sheltered area to prevent any impact of outside temperature or water.
In this setup, you can see the 4 Galileo boxes up above, monitoring the data and sending them directly to the cloud.
Whenever the touch sensor passes 2 railings and hits them both, it will know that you're near a plant, so it'll stop and adjust itself by going back 1 centimeter, so the plant will be able to get its amount of water.
What you're seeing here is the beagle bone black that's controlling both the motor, and also it's controlling a solenoid valve to discharge water at the right point of time. Here is the circuitry based on using a breadboard that has the controls and the logic built into it. The biggest challenge is actually trying to get power with a range of 5 to 12 volts, depending on, because the motors needed 12 volts of power to be delivered.
So this is one of our 4 Galileo boards containing 5 different sensors, and each sensor is connected to each plant treatment. We use the moisture sensors to collect constant data and send to the iCloud.
In the future, the plan is to have the Beagle Bone Black use the soil moisture data, current weather data, current temperature information in order to target a specific amount of water to each plant, and thus control more accurately the amount of water necessary in the system.
I think the most fun we had during this experiment was watching the plants grow and form into full-grown pea pods and plants.
So I hope you took away a couple of things here. Number one, this is clearly not a commercially ready solution, right? But I think hopefully what it gets you thinking about is what are the possibilities here? And I think there are many possibilities that perhaps we don't even foresee today, but the opportunities are there. Number two, you notice this is high school kids doing this work, which is absolutely phenomenal, right? So the other factoid I'll share with you is I read once that of all the Nobel Prize winning physicists, all of them had done their key work that was the breakthrough before the age of 35. Pretty depressing for almost all of us here in the room, isn't it? But the point is, the other takeaway that I have is, how do we engage the next generation, which is going to create these new technologies, these new opportunities for us, look at things differently than the way that we've looked at things, and it's hard for us to change our mindset because it's the way we've always done it. So on that, let me leave you with just this one last thought, which is we do need to think differently. How can we think differently? And I'll just give you a simple example. But the premise here is we have dollars that are invested in water, in water conservation, and water efficiency. How do we make sure those dollars flow towards the points that give us the biggest return on investment? And we're not there today. Today, all of us, including ourselves, operate in silos. How do we merge that so we look at it differently? An example would be the recent investment that I showed you. We expanded the Chandler reverse osmosis facility. It results in a savings of about 2 million gallons per day saved. If you take that same amount of capital and could convert agricultural fields to drip irrigation, you would get about 20 to 30 times the amount of water savings. So how can we set up a system whereby, again, the capital flows to where you get the biggest return on your water? So a thought for us maybe that we can have some more dialogue over the next couple of days. So with that, let me give you a parting thought. These are the 3 Intel founders. Andy Grove on the left just passed away last week. Some of you may have seen that. The one in the middle is Robert Noyce, and the one on the right is Gordon Moore that I referred to earlier. But Robert Noyce was always a visionary. He was looking ahead for the company, and a quote here from him: "Don't be encumbered by history, go off and do something wonderful." I hope that's the case here as well with us, with water in the Southwest. Collectively, we can accomplish something wonderful. So thank you.
Hi, my name is Ann Castle. I'm with the University of Colorado. I was wondering if the savings, equipment, and changes that you made can be justified economically in the cost of water reduced, or if not, if it's a sustainability primarily consideration.
Yeah, so the answer is both. So we do some projects. So every year we go out to our engineers and say, submit ideas for what you can do for energy savings, water savings, utility savings. And those have to have a ROI of 5 years or less. They get rolled up and then we go execute them. We'll spend about $30 million this year doing that. So there are projects that come up for water conservation that meet that 5-year ROI, and we go do them. The example I showed with the City of Chandler is more of a strategic investment. That doesn't have a 5-year ROI, strictly based on water use. But it does have an ROI when we look at our business, and if we want to grow our business, we can't continue to just use an infinite amount of water. And so that's where the ROI comes in from a business standpoint, in things where the water itself doesn't.
So you mentioned having money flow to the biggest impact, and I'd be curious as to what your personal opinion is. What's the biggest barrier to that happening today?
Well, I think there's not a mechanism today, although, and I'm interested to learn more. I heard from some of the panelists this morning about some activities that are going on with water trading and water investments. I think that's a great start. I think today there's not a mechanism set up to do that openly. To have a system whereby one could buy and sell credits, receive credits, sell credits, and do that in an open manner. I'm not a policy expert, but I know that, based on the current laws, there's some challenges to doing that and how one would go about doing it. I like the ideas that were thrown out this morning, though, that perhaps there are opportunities to do that voluntarily, and it sounds like some of that is going on. And so I think the more that like-minded people can get together and talk about those voluntary opportunities, the more the examples can be set up for how this can be done, even in the legal framework that we have today.
So join me in, do we have another question? One more quick question.
Hi, my name's Karen Yakos. I was with Kerr Green Mountain as the director of CSR, and now I'm about to be with Ceres, so I get to come to more of these. I was here last year in Las Vegas. But I have a question. And I'm sure this is going to come up on the tour, and I just can't stay. I need to get back to Vermont on Friday. But when you worked with Chandler, and there were two things that you showed up there that showed probably a public investment, water plants and different technologies. How did that conversation come to be, and how did it, who approached who? I mean, how did you get to be that, how did you get the investment from the city?
Yeah, so part of the investment was building the plant in the first place, and there were obviously incentives that were given to Intel to come to the city of Chandler and to build a plant there. However, the water, the plant that you guys will go see on Friday, for those of you who are interested, that's funded by Intel. And then we turn it over to the city of Chandler, they run it. But all of the capital comes from us. So it is truly a partnership between us and the city of Chandler. So we're not just asking them to build the infrastructure for us, we're actually putting up capital dollars to fund that infrastructure development. Now that said, I don't want to take away, the city of Chandler certainly been a wonderful partner to work with and done a number of things in the city that have supported the growth of our business. So I don't want to imply that we're doing everything and they're not. It's a true partnership with both coming to the table, both putting up dollars and resources to make it happen.
All right, so I think that's it for questions. Join me again, please, in thanking Todd, Brady, and Intel for their support.